Okay, so for our last one, I've given a couple of different graphs, and we're just going to take a look at each one of them. Each of the graphs below show some sort of a temperature, capital T for Celsius in temperature, and there is a function of time for T hours at some different points and locations of the graph. So I want to know which of these graphs has a rate of change of 5 degrees centigrade per hour, and a vertical intercept of negative 10 degrees centigrade. And I also want to know which graph has a rate of change of negative 10 centigrade an hour and a vertical intercept of 20. So let's just take a look at each one of these graphs and let's break down some of their features. First off, let's go with I. I notice one I is that we're starting at plus 20 at 20 degrees. And this is going to be a vertical intercept. It's intercepting our vertical axis, vertical int. And I do notice that it looks like it's going downwards here. Looks like going down. And this tells me that there's going to be some sort of a negative rate of change. Okay, I don't know what that rate of change is, but I know it's going to be negative because it is going downwards. Let's go ahead and let's look at II. So this one over here, we're starting at negative 10. So it's got a negative vertical intercept. Negative 10 degrees centigrade is going to be our vertical int. And this time it definitely has a positive rate of change. You know, since we're using, T's and capital T's, I'm going to just circle that. I'm going to circle that, negative and positive. Our third graph looks like we have a 20 degree vertical intercept. Once again, it looks like negative rate of change. Since it's going downwards, I'm just going to make this into a plus sign here and a negative sign in there. And on our fourth graph, it looks like we have negative 10 vertical intercept. And we have a positive rate of change. Oops. Rate of change. Okay, so now let's take a look at this. First off, for A, we are looking at which of the graph has a rate of change of 5 degrees Celsius per hour and a vertical intercept of negative 10. So we're automatically on this guy or this one. And we're looking for a rate of change of 5. So we don't actually know what the rate of change is. We know this is positive though, so it's definitely on these two. And our vertical intercept is 10 on each. So we know it's between 2 and 4. So let's just look at 2 and let's look at 4. And let's see if we can figure out what the rate of change are for both of these. So let's do our second graph first. I have a bunch of points listed for me on the graph, and it looks like each point is going up by 10 and over by 2. Up by 10 and over by 2. So if I wanted to get my rate of change for this one, I could say that my rate equals my change in my dependent variable, and it looks like it's going up by 10, over by 2, up by 10, over by 2. So this is going to be a 10 degrees Celsius change, positive, every time I see a new point. And it looks like I'm going over 2 hours each time. This would be 5 degrees Celsius per hour. Over here on 4, it looks like I only have 2 points, one here and one over there. Again, my rate looks like it's going up 10 degrees. From negative 10 to positive 0. That's a 10 degree jump, positive. But it looks like this is going to be taking 10 hours to do. So this means that's going to be 1 degree Celsius per hour. I'm looking for 5, so I know that my question for A should be graph 2, graph 2. Now, we're going to go one step further, and I'm actually just going to go ahead and give the equation for this graph. Now, when we're giving the equation, I always want to start off with my dependent variable, which is going to be capital T. And I'm going to give this to be equal to the rate of change, which is going to be 5. 5, that's just the number that we're using. My independent variable is going to be small t, and I'm going to have my vertical intercept afterwards. Okay, so that's actually going to be my equation for it. I know the question isn't asking for that, but this is something that we're going to have to do later on. Equation for graph 2. All right, so let's go ahead and now let's look at question B. Which graph has a rate of change of negative 10 degrees centigrade per hour and a vertical intercept of 20? Well, that's only going to have to be either this one or this guy. Let's figure out graph 1, what my rate would be here. I only have 2 points. I have the first point up at 20, and I have the second point here at, it looks like a y-coordinate of 0. So that jump to go from 20 down to 0, that looks like this is going to be a negative 20-degree jump. And it takes from 0 all the way to 10 hours to do. So this rate is going to be negative 2 degrees centigrade per hour. Let's go down here and let's take a look at the rate for this one. Now, when I'm looking at rate graph 3, again, I start at 20. Again, I'm dropping to 0 degrees, reading the y-axis. So that's, again, a negative 20 jump. But this time, it only takes 2 hours to do. So this is going to be my negative 10 degrees per hour. So definitely, graph 3 is going to be the case where this is. And again, it's not asking, but I am going to give the equation for it because we are going to be expected to do that pretty soon in this course. So I'm always going to give it with my dependent variable first, and I'm going to go ahead and list my rate of change afterwards. No units are necessary here. My independent variable t, and then I'm going to have my vertical intercept plus 20. And this then is going to be the equation for my third graph. Okay, perfect, all done.